Today we're going to continue reviewing fractions, and this is part of a playlist looking at things that you learned before grade 9 but are very, very important and show up all the time and are worth remembering. So we did a little review in the previous video, and today we're going to look at the two concepts which are more or less the same concept. One is equivalent fractions, and the other one is reducing fractions. And you remember what these are even if you don't know them by their name. So the idea that we looked at last time, that a fraction is an answer to a division question, so 3 divided by 4, if I did that as 3 over 4, if I did that on a calculator, it would give me a decimal, 0.75, but that's not the only combination of numbers that when I divide them give me the same answer. So for example, I could also do 6 divided by 8, and if I type that into a calculator, it would also give me 0.75. I could also do 9/12. 9 divided by 12 would also give me 0.75 calculator. And you know the pattern already, which is if I multiply, say in this case, this times 2 and this times 2, 3 times 2 is 6, 4 times 2 is 8. If I multiply both the top and the bottom by the same number, I will get fractions that give me the same. And the way you think of that graphically is, let's say I have a chocolate bar that I divide in quarters. If I multiply both the top and the bottom number by 2, let me just color in the thirds part of it, and I add another cut right through the middle, I now have both twice as many colored in pieces and twice as many overall pieces, but the amount of chocolate bar has not changed, or the amount of colored in picture has not changed. And this is incredibly important, and we use it all the time. Now, the process of going up is not all that useful. The process of going down is extremely useful. So let's say that I have 10 over 20. What I would want to do is look for a number that divides both of them. So in this case, it's obvious they both divide by 10. And just like I'm allowed to multiply both the top and the bottom by the same number, I'm allowed to divide both the top and the bottom by the same number. And I said we never use the divide sign. I like to use it as a kind of scribble note to myself where I explain what I'm doing. So I go, oh, okay. So what I do is I do divide by 10, divide by 10, and this is equal to 10 divided by 10 is 1, 20 divided by 10 is 2, so 10 over 20 is the same as 1/2. Why is that a good thing? Well, 1 and 2 are smaller numbers than 10 and 20, which means anytime I have to do mental math, I can do it much faster. I can also, if it's something where I need a decimal, I remember that 1/2 is 0.5. I may not necessarily remember that 10 divided by 20 is 0.5. So anytime you can make the numbers in a fraction smaller by dividing the top and the bottom, so reducing it to an equivalent fraction. And when you can't go down any further, this is what's known as a fraction in lowest. And I had a grade 8 teacher that told me, and I believe her, that no fraction is ever truly happy unless they're being written in lowest terms. So 99.6% of the time, if you see a fraction and you can reduce it and make the numbers smaller, you should do it. Now, this is, I think, the real reason why way back when we wanted you to memorize your times tables. It was not so that you could do multiplication more quickly, right? We have calculators that can do that, but it was so that I could spot the numbers that divide into other numbers more quickly. So let's say, for example, that I want to do 18/45. Okay? Now, I can spot what I need to divide by fairly quickly if I know my times table, says, okay, I know 18 is in there somewhere, I know 45 is in there somewhere, oh, they are both in the 9 times table. That's why I want my times tables memorized, not so that I could do 9 times 6 or 9 times 4, 9 times 6, but so that I can look at numbers and I can kind of go, that looks like a number that's divisible by 9, and so does that. I bet, and you can use a calculator, you can check, if I divide them both by 9, I will get something. So I could do divide by 9, divide by 9, and then this would be 18 divided by 9 is 2, and 45 divided by 9 is 5. And then you can do that, and that makes it much simpler. Now, what they do tend to tell you, and this is something I disagree with, is that you should always look for the biggest number that works. And that's not always a good idea, because looking for the biggest number that works is sometimes a waste of time. I will show you just how to do this so it takes a little bit less time. We'll do the same question, 18 divided by 45. Now let's say I do not recognize the 9 straight away. That's okay. I could look and say, do they both divide by 2? Well, no, they don't. That's an odd number. Oh well. Do they both divide by 3? Yes. All right, so that's fine. So instead of doing divide by 9, I could do divide by 3. Divide by 3. It's still allowed. Divide the top and the bottom by the same number. So this is equal to 18 divided by 3 is 6, and 45 divided by 3. And you can always, because you learned how to tell time on a watch, you can do the 15 times table really easily, right? 0, 15, 30, 45. So 45 divided by 3 is 15. Okay, now I have this new number and I say, oh, okay, both of these numbers divide by 3. Okay, and so 6 divided by 3 is 2, and 15 divided by 3 is 5. And that works like that. Now, the reason they say it's better to do it with the 9 than it is to do it with the 3 is because you noticed I got this in 1 step, and in this I took 2 steps, which is true. However, if the numbers get ugly, it is possible that the time it takes me to figure out that 9 works is longer than the time it takes for me to figure out first that 3 works and then that 3 works again. So I always say, rush and take the easy one. So if you see something easy like, oh, it's an even number, I can divide them both by 2. Oh, they both end in a 0, I can divide them both by 10. Oh, they both end in a 5, I can divide them both by 5. So it's okay to spring and reduce with the first number you see. So let's make one up. And I don't know the answer to this in advance. So let's do 200, let's actually write with a pen. 235 over 500. I don't know ahead of time how this is. Give me something that is more likely to turn out a little nicer. Let's do 240. Okay, now I could go look for the biggest number, but I think it is better just take the numbers that you see. So I do know that I can do them both divide by 10. That's easy. 24, 50. And then, oh, I can do both of them by 2. And so this is 12 divided by 25. And 25 only divides by 5, and 12 is divisible by 3 and 4. So that's as low as it goes. And I could have looked, and so the number that would have gone faster would have been the number 20. But I think this kind of approach where I work down slow and steady, I think is much, much better. So that is reducing fractions. Remember, every time you see a fraction, you always want to be thinking in the back of your mind, can that be an equivalent fraction with smaller numbers? And that's something we just do constantly as a churn. And in the next video, we'll look at some more operations with fractions. Again, I think you already know all this stuff, but it's nice to have a refresher, and it's nice to remember that, oh, we're going to be asked to do this. It's coming. So see you soon.